Alright, so last video for this chapter. We are now solving rational equations. So there is an equal sign now on all these problems. We actually have to find out what x value is to solve the question. There's a few steps in doing this. Okay? First step is find the domain restrictions of the problem. The reason why is if you get an answer but it doesn't fit in the domain, you can't be an answer. And sometimes that happens. So it's good to list that first. So right away we have to do that. Find an LCD so you can multiply both sides by the LCD. Now, this is different than when you're adding and subtracting. You're just multiplying. Think about when you want to get rid of a fraction. For instance, if I have x over 2 plus 3y equals 5. One way to get rid of this fraction, multiply by the least common denominator. Well, that would be a 2. So I multiply everything by just 2, not 2 over 2. And then you get x plus 6y equals 10. Now there is no fraction in my equation. And that's basically what we're doing right now. We are going to multiply basically multiplying once by that. So, find the LCD, multiply, solve. Write solution in set notation, check against domain for extraneous solutions. So, let's look at what happens here. My LCD, well first of all my domain restriction here is x. That x cannot be what? Well, if you look at the bottom of these fractions, x can't be 0. Everything else works fine. My LCD for this case is going to be an x and a 2, so 2 times x. Okay? So what I do then is I'm going to multiply, and I'm going to do this up here. I'm going to just multiply this whole equation by 2x. That's it. I'm not multiplying it by 2x over 2x because that does nothing. With equations, you can multiply both sides the same way. It's like solving, and make it look better for yourself. So let's do that. 2x times 4 is an 8x. 2x times 5 is a 10x equals negative 22x over x. And now the reason why we did that, look what happens. This fraction, the x's go away. So it's just 8. This fraction, the 10 and the 2 become a 5x. And there's no more fraction. Over here the x's go away, and we're left with 8 plus 5x equals negative 22. Hopefully you guys should be able to solve this. You get 5x is equal to negative 30 when you subtract 8. X is equal to negative 6. So we got x is negative 6. Look at our domain. Can it be negative 6? Yes, it can. The only thing x cannot be is 0 in this case. So my answer is x is negative 6, and it's in the bracket because it is in the domain. And that's all. That's all you do. So key, again, find the domain, find the LCD to multiply it by, and then simplify and solve. So my domain for number 2 is x cannot be 2. And I got that because I look at the bottom of the fractions, kind of like when we were looking for our holes in vertical asymptotes. 2 would make that a 0 on the bottom of a fraction, which we cannot have. Now my LCD, again, all it is x minus 2, because there's nothing else on the bottom. So I'm going to multiply everything by the quantity x minus 2 only on top again, because it's an equal sign, I can do that. So this becomes 5x times x minus 2 over x minus 2 equals 7 times x minus 2 plus 10 times x minus 2 over x minus 2. And again, the whole purpose of this is so that we are left with no fractions. So I'm left with the equation 5x is equal to, if I multiply that out, you get 7x minus 14 plus 10. Alright, I'm going to keep solving. I get a negative 2x is equal to a negative 4, so x equals 2. Well, look at the domain. Can x be 2? No, it cannot. This is where people get things wrong. You get x equals 2 and you're like, yeah, I got an answer. No, that's not an answer. Because if you plug it back into the original equation, it gives you no solutions. It can't work because you cannot have 0 on the bottom of a fraction. So this is an extraneous solution. So we checked with the domain, we cannot have that answer. So technically, the answer to this problem is there are no solutions that will make this work. However, there's an extraneous solution of 2. That works if we change the equation, which we did and got rid of the fractions. But it doesn't work with the original. Okay? And number 3. Let's do the same thing. Find out an LCD. First things first though, factor this. Remember, x squared minus 4 is the same thing as x plus 2 and an x minus 2. Okay? So my domain restriction then is that x cannot be plus or minus 2. So my LCD here is going to be an x plus 2 and an x minus 2 because that's all I need to multiply by to get rid of my fractions. So you're looking for what will cancel out the bottoms of the fractions. That will cancel out both of this and that. So what we're left with, and as you get good at this, you can start going, okay, well in this fraction, the x minus 2's are going to cancel out, so I'm left with 3x minus 2, and there's going to just be an x plus 2 with it. The fraction will be gone. Equals, these will cancel out with both of these, so we're just left with 6, plus, and then we have x squared, x plus 2 and x minus 2, which is, again, x squared minus 4. Okay, so I'm going to simplify this. We get 3x squared minus 2x plus 6 is a plus 4x minus 4 is equal to x squared plus 2. Get it, move everything over, set it equal to 0. So subtract x squared, we got 2x squared. We still have a plus 4x minus 6 equals 0. Factor, don't have to do Batman right away, because look what happens. You don't have to do Batman. Now we can factor this nicely. We get x plus 3 and an x minus 1. So that means when I set these equal to 0, I get x is equal to negative 3 and x is equal to 1. Double check with the domain restrictions. The domain is that x cannot be plus or minus 2. Well, it's not. It's negative 3 and positive 1. So that means my answers are negative 3 and 1 in the set. Member set notation. Alright, so that's what you do when you have a few terms. Now, if you, for instance, have just 2 equal fractions, you can cross multiply. You can also do the other thing where you multiply by the LCD, and you might lose you might get more what happens with that is you might not get an extraneous solution then, but I'm not going to be as concerned about that as long as you do it correctly. So I'm going to cross multiply whenever they're equal. It's just faster. So cross multiply means multiply these two together and then equal to multiplying these two together. So I get 2 times x plus 1. And I probably should figure out what my domain restrictions are first. Remember, factor this out, and it's an x and an x minus 1. So the domain is that x cannot be, x is all values such that x cannot be 0 and positive 1. Alright, so let's cross multiply and solve this. I get x squared minus x is equal to 2x minus 1. I move the thing over, and I get x squared minus 3x plus, oh, what did I do wrong? I know what I did wrong. I was supposed to multiply the 2 and the 1. You have to multiply, distribute. So this becomes plus 2. So then we get x minus 2 and x minus 1. So we get x equals 2 and x equals 1. And again, 1 is one of our domain restrictions, so my actual solution is that x is 2 with an extraneous solution of 1. Okay? Again, if you did it the other way and multiply both sides by x times x minus 1, you would not have gotten the extraneous solution. You would have instead just gotten the real one, which can happen, and that's fine. But it's easier again to cross multiply. Down here, this is the same thing as x times x plus 4. So my domain restriction, I'm going to just do over here so I have it. X value such that x cannot be negative 4 or 0 again. Cross multiply, this distributes into that. This stays the same. I get x squared plus 4x is equal to 3x plus 12. Move over everything. And when I simplify, oh, how did that change color? There we go. When you simplify, when you factor, you get x plus 4 and an x minus 3. So you get x equals negative 4 and an x equals 3. Again, we have an extraneous and a real. Our real one that works is the 3, but x cannot be negative 4. Okay, why don't you guys try the last one? The last one's an old one. Okay, it's not a cross-multiplying one. So find out the common denominator, multiply by everything by that, and then solve. So pause the video. X cannot be negative 1 or 1 for this because this is the same thing as x plus 1, x minus 1. So that means I'm multiplying everything by x plus 1 and x minus 1. So on this one, the x plus 1s will cancel, so I'm left with 2 times x minus 1, plus this one, the x minus 1s will cancel, x times x plus 1 equals 2 times, and then all these will cancel, so we're just left with 2. So this is what we're solving. So we get 2x minus 2 plus x squared plus x equals 2. I have an x squared plus 3x minus 4 when you move the 2 over equal to 0. So I can factor that, probably 4 and 1, x plus 4, x minus 1 is equal to 0, x equals negative 4, and x equals 1. Look at your domain restriction, x can't equal 1. It's not possible, so we plug in our real answer here is negative 4, that fits in our domain, and the one that does not is 1. Okay, so really the only difference with solving is that you don't have to multiply by the top and the bottom. You're just multiplying the tops to cancel out the bottoms to make it easier for you to solve. And that is all that is extra for the test. So this is the last lesson for the chapter. There are some videos on how to solve certain problems, test review questions, and also I'll help you in class and go over anything you guys need. Nice quick chapter.